Okay, so we're going to do our first two-dimensional practice problem, a horizontal launch problem, the first of the ones that we were working on. Again, if you have not done these problems yourself, you want to make sure that you go back and try them before you go through the video solutions. You will not do yourself any favors by just looking at answers. You have to practice how to process and read these and what assumptions that you have. So try them yourself. If you're getting stuck on the setup, send me an email and we'll get you situated. All right, so a tennis ball is struck such that it leaves the racket horizontally with a speed of 28 meters per second. The ball hits the court a horizontal distance, 19.6 meters from the racket. And they ask, what is the height of the tennis ball when it leaves the racket? Okay, so let's take a look at this. Best thing to do first is to do a diagram. So here's the ground, and here's the ball leaving the racket with a horizontal velocity of 28 meters per second. It's going to have a parabolic path, and the distance from here to where it hits the ground is 19.6 meters. And we want to find this height, which is the initial Y position. Okay, so let's go ahead and look at our givens. So I'm purely horizontal for this initial velocity. That means my x component is 28 meters per second, and my y component is 0 meters per second. I have an acceleration in the x direction of 0 meters per second, which means my initial horizontal velocity and my final horizontal velocity will be the same. Some students will be tempted to put a 0 in here in the y final velocity. That is absolutely not the case. If you're not sure about it, smack the table. That pain you feel in your hand is a fact that you are not landing gently on the table at 0 meters per second. You have some velocity. The ball will have some velocity. So we don't have anything at this point that we can stick in there, and I'm not sure that we need anything. We need to think about this a little more carefully. So our acceleration in the y direction is negative 9.8 meters per second squared. Oops, let's watch our units here. And our displacement in the horizontal direction is 19.6 meters. And so we take a look, that's all we know. And I want to find this y displacement. So on this side I have 2 of the 5 variables that I need, so I can't solve anything in here without time. I do have plenty of information in the x direction to find the time, so I put a need in here. And once I find time, then I can use the no VF formulas to find my y, initial y position and displacement. Okay, so the formulas we're going to use, in x there's only one formula, that's x equals v naught xt, and then in the y direction, when we get done, we will use the no VF formula, and the no VF formula, just to jot it down here, is y equals v naught t plus 1/2 a t squared, and that is a subscript on these y's or subscripts. Okay, so let's start here in the x direction and solve for time. So time is equal to x over the initial x velocity. So time is equal to 19.6 divided by 28. Good habit to get into to just leave the signs in there. So time will equal 0.7 seconds. And I'm going to write SEC here only because in a couple of these videos my S looks like a 5, and so it prevents a miscopy and so forth, and is clear for you guys. But as you could put an S there, it's absolutely no problem. Alright, so I have 0.7 seconds. I'm going to now plug into this formula. So my initial y velocity is 0, so I don't even have to deal with that. So I have 1/2 a, which is negative 9.8, and times my time, 0.7 7, and don't forget your squared. We're repeating this video because in my first go round I dropped that off. It's a very common mistake. Please make sure that you pay careful attention to it when you're checking your work, that you've not only put it in the formula, but that you've also squared it when you put it in the calculator. So we're going to type this in. That's 0.5 times negative 9.8 times 0.7. Make sure you hit that squared button, that x squared button, so that the 0.7 is squared. And we hit our enter, and we should get negative 2.401 meters. Now this is the y displacement, and indeed it's negative. I started here and I went to the ground. But the question asks, what is the height? So the answer to the question is, the height is 2.4 meters. So the answer, the launch height is 2.4 meters. It's a scalar. You could put 2.4 above the ground is helpful, but not necessarily essential. We're assuming that we're not going to be hitting tennis ball underneath the ground. Okay, so we're in good shape. That's our answer.